So, hello everyone. How are you all doing? Can you hear me okay? Nice. So, happy Friday or Saturday to you all, depending on where you are. It's like got everything set up here. Thank you all for being here. Now, it's raining pretty hard where I am right now, so there might be some background noise, but hopefully it won't be too much of an issue for you all. That said, happy Friday again, and it's about time to get started. Welcome to this week's OffSec livestream. My name is John. I go by the moniker Servus. So this is my first time or my first stream in the OffSec livestream, but I have been lurking around moderating the previous OffSec Academy and OffSec live chats. I'm also part of the Academy team together with Nasro. You might remember him. He did the OffSec live stream last week. In that session, he showcased a WEB-100 module on proxying and burp. Now, this week will also be related to web apps, but this time around, we will be looking at a WEB-200 module. It's called Introduction to Cross-Site Scripting. Now, offensive securities web attacks with Kali Linux, or more commonly known as WEB-200, is a course created for you people who would like to perform basic professional web assessments. It's perfect if you're aiming for job roles like web app pen tester or web app developer. Now, it's part of our Learn subscriptions, so you can get access to it via Learn 1 or Learn Unlimited, since Learn Unlimited includes all our online courses. Either of these options will give you access to, or will also give you access to our Learn Fundamental bundle, basically all our 100 level content. And with the course introduction out of the way, let's get started. So yes, hopefully the demo gods will be in my favor. Thank you, chat. Now, chat, what do you know about cross-site scripting? Anybody? Nice. Stored and reflected variants. Very nice. We'll exactly go through both of those later. That's good answers. Now, cross-site scripting is related to injecting JavaScript for remote execution. Yes, exactly. Executing JS. XSS is actually a type of code injection. Wow. You guys are getting it right. So it occurs when an attacker injects malicious client-side code to a trusted application or website. Now, XSS can be any kind of client-side program or script, but it's mostly JavaScript that is injected in a web app and then executed from within a victim's browser. Before I get started with the lab machine, let's have a simple example to demonstrate this concept. Now, I have here a very simple PHP web page that will greet the visitor whose name is included as a get parameter in the request. For example, if I do something like I use the get parameter name equals test, let me enlarge that for you. we see we are greeted by the web page. Very simple, right? But also very boring. It's a static page. It doesn't do much to attract visitors. What developers do to make their website stand out is, aside from maybe adding layout, colors, formatting, and images, is to use JavaScript so their website will be more interactive. Now, developers can use JavaScript to create slideshows. You can update content without refreshing using JavaScript. You can control what content is displayed depending on what users do using JavaScript. So JavaScript is really, really great. In fact, it's one of the most, if not the most used programming languages right now. A lot of it exists in web pages. So chat, my question to you now is, how do we add JavaScript into our simple web page? Does anyone know? Botish. Oh, sorry about that. Is the text or is the font clear enough? Exactly. We can use script tag. Now, what developers would use is, let's do Vim. They will add JavaScript via script tags. They can do it inline, such as something like this. Or they can add external files with the src attribute. So let's just say I'll add a file located in the JS folder called slideshow.js. Now, referencing an external JavaScript file has the benefit of making the JavaScript code reusable among several HTML pages. But basically, JavaScript has significantly improved the quality of web pages. However, it did open up a new attack vector. Just to be clear, the issue is not with JavaScript itself, it's just a scripting language. The issue that this introduced is due to web applications outputting untrusted user input. Now, this is unlike most web vulnerabilities that are usually caused by accepting unsanitized user input. For cross-site scripting, it's more important for the output to be properly encoded. Now, some people are saying no input validation. Now, input validation can help, but for XSS, output sanitization is a lot more important. Now, let me show you this. Let me exit this first. And let's say I'll use so we get a pop-up when let me do this so it will be clear. When I specify the name script alert 0 script. Now, if you view the HTML code, you can see our name here. Now, since the web app did not properly encode the script tags, the browser treats this as starting and closing tags for JavaScript code and will execute every line inside of it. Let me make this bigger. Sorry about that. Now, in this case, it's just a simple pop-up, but it can be anything that I want. Now, even if the application accepted script tags in the info or in the get parameter, if it was properly encoded during output, so it will look something like this. Let's edit this. And let me copy. So it was if the web app properly encoded the output, like what you see here, if I press enter, you can see it no longer executed, and our script is actually shown as text. We would not be able to exploit this vulnerability anymore. Here, if I click, right click and can't, give me a moment, chat. Can't edit this, but either way, basically, if it was HTML encoded, the browser will treat it as text and be correctly displayed in the browser, not interpreted as HTML tags. Now, all good so far, chat? Now, if unsanitized user input is displayed or included anywhere in a web page, then that web app is vulnerable to XSS. Attackers can use this vulnerability to execute JavaScript of their choosing. So chat, I want to ask you guys, who are the victims of XSS exploits? Exactly, the people visiting the web page. So unlike a lot of exploits that target web server or that target the web server, XSS exploits target the clients or the visitors of the web server. The consequences vary, but since JavaScript is able to control everything in a web page, there's a large range of possibilities. For example, an attacker can use XSS to obtain crucial information, your passwords, personal info. They can perform actions on your behalf, like submitting forms. They can be annoying, such as redirecting you to a web page. Now, there's a lot of possibilities, and I hope that was a clear explanation or introduction to XSS. Let's now go over the attacks covered in the course. Now, stored XSS stores your payload in the server but is still targeting the clients. It's gonna be stored in the server but it doesn't do anything to the server. Instead, once the server extracts your payload and uses it as content for its web page, then it will exploit clients. I hope that answered your question. Nice. Now, for this module, WEB-200 gives us access to the Xss Sandbox machine. This web server hosts a collection of web apps vulnerable to different kinds of XSS. It has a lot of moving parts, so let me first go over them. The application is split into 4 sections. The left side is our hacker side, where we can browse the various pages and test exploits here. The right side is actually pretty cool. It's a simulated victim. Now you can think of this side as a way to control a visitor to the web app that we will be exploiting. You can control their browser settings here, like we can enable HTTP only cookie if you want a more secure web server. We can simulate user actions like keystrokes, entering credentials, using stored password mechanisms like in Firefox, and other stuff. Now, if I click render, a screenshot of the simulated victim's browser is sent to us, so we can examine what happens when they visit the web page and execute our attacks. We can view the results of our attacks this way. Now, the information page, I'll go over that in a bit. So, let me first, let's do that. I'll go over the info page now. The info page, the current tab we have right now, it's not vulnerable. It's not meant to be attacked. Its purpose really is just to provide information on how this sandbox works. So it gives you like a manual on how to make use of this website. Hope that answers your question. Meanwhile, we have search, blog, survey, and all the other applications here are vulnerable to a specific type of XSS. When I visit any of these tabs, the response will be displayed in this left panel here. Now this panel, you can see here, it has a URL bar, imitates a browser. You can think of this as a mini browser. This mini browser is being rendered by our own browser. That means that any XSS attacks we perform or any JavaScript we execute or inject will be executed by our own browser. Now this is great for testing. So now that we know how to use the sandbox, let's get started with our assessment. Now the first application I want to go through is search. Now, when doing web assessments, we should always thoroughly check all functionalities a web app has. That way we can create a plan on how to teach or how to test each one. In this case, it seems like we can only do a generic search. Let's try it out. Now, the search doesn't seem to be working, but we can let's see what happened. If we carefully look at the URL, we see that our search term is added as the value of the get parameter s. We also see that our search term is displayed in the web page. So the web app indicates what we search for. And this is exactly the kind of behavior you're looking for when you're testing for XSS. You want to identify if any input you control in the web app, in this case, we control the search term, is embedded in the HTML in any way. Now, let's start testing if it's vulnerable to XSS. Now, a good place to start is always, in my case, I always like to try HTML injection first. So, instead of injecting JavaScript code, let's try adding some HTML tags. Let's try something like h1 OffSec h1. So h1 is a header tag. That would mean that if I am able to inject HTML, OffSec will have a different format, or will have a heading format. Let's try that out. Let me read the chat for a bit. Exactly. If you have reflection in the link, that's also an indicator of that, or a possible indicator of XSS. Now, we see our search term again. And if you were paying attention, you would notice that the font is much larger than before. Let's inspect the HTML once again. So as you can see, here are HTML tags. And these tags cause our search term to increase in size. Now we proved that we can inject HTML. Being able to inject HTML doesn't always mean that we can inject JavaScript, but it is a great indicator. So now let's try with JavaScript. Let's go back here. Chat, any suggestions of what to try? Yeah, exactly. Yeah, exactly. So, a lot of people, when testing or trying to prove a web page is vulnerable to XSS, the usual proof of concept is a simple alert message. That way, we get a pop-up if it works. It's very simple, very short, and very unlikely to cause error, or very unlikely to have any errors. Now the course does go through more advanced JavaScript payload like keyloggers, but due to time constraints, we won't have time to go over those. What I want to focus on in this session is understanding how XSS is discovered and exploited. Now I just want to set that expectation. Let's try this out. Let's click search. Cool, we get our pop-up. Now we proved the web page is vulnerable to XSS since we can execute JavaScript of our choosing. Now chat, does anyone know how we can use this exploit on other users? How can I exploit other users with this XSS? Nice. Send the link with the payload, exactly. So if we look at the URL, we see our payload included in the get parameter. Now, if we give this link to unsuspecting users and they browse to it, they will get a pop-up. So let's try that out. To test if this link actually works, we can use our simulated victim. Now when I click render, our victim or our bot will browse to the same URL our mini browser has with the options specified here. Now I don't think I need to change anything right now, so I'll just click render immediately. Perfect. As you can see, our simulated victim also has a pop-up. Now this pop-up is not on our browser. It's on a screenshot of the simulated victim's browser. So we've proven that attack works as long as someone or our victim visits the link. A reminder to you all to be careful of any links you click. Now, whenever a get or post parameter is reflected in the web page in any way, like in this case, it's called reflected XSS. Reflected XSS usually involves sending links that contains a payload in the get parameter to the user. It's one of two types of XSS. The other one is stored, which we'll go through later. Now in our scenario, the get parameter S, this one, was included in the web page, indicating the search results. Now, unlike phishing campaigns that use realistic fake links, reflected XSS actually use the actual domain of the target, but adds malicious JavaScript in the URL. So it's a bit more believable since the domain is correct, but it's still malicious. Now, both reflected and stored can be further categorized as either client or server, meaning there will be a total of 4 variations: reflected client, reflected server, stored client, and stored server. Classifying XSS as server or client really comes down to whether the server is the one appending the payload to the HTML, or if client-side JavaScript is appending the payload to the HTML. Now we can easily verify this by looking at burp. I have burp running as a proxy, and this is our exploit. So if we look at the response, I hope that burp is clear to you all. If we look at the response, we see that the moment the HTML arrives to our browser, it already contains our injected script. Let me try something. User options. Hope that's better. Nice. So let me go back a bit. So the moment HTML arrives to our browser, it already contains our injected script. This means this is a reflected attack, since our payload is reflected in the HTML. And it's also a server XSS, since the server added our payload to the response, meaning this is reflected server. All good so far, chat? Nice. Now, if our payload was not present originally in the response, but rather dynamically added via JavaScript, for example, the web page would make an AJAX request to the server and then update the HTML, it would be reflected client. Now, if it's still a bit confusing, don't worry, we still have a lot of examples. Let's move on to the next one for now. So our next example, let's have a look at the survey app. So it's a form that allows us to answer questions on the survey. Now we see that we are answering the survey as the user JSON. Now I didn't have the option to choose my name before coming to this link, but it does seem like we can set the name with the name get parameter. Now chat, does any of this look interesting to you, or does anything look super familiar? Let me clear this for now. Exactly. So if we look at the URL, we see that most likely its value, the name, is reflected in the welcome message of the web page. Now, this is eerily similar to our first example, but we can't just assume that whatever is in the get parameter is reflected in HTML. Let's test this out. As always, let me first start with HTML injection. Perfect. Now, a lot of you are saying SQLi injection. That is definitely something you can try. But for now, we'll focus on this side first. We'll move on here later. Now, as you can see, our H1 tags have modified the format of the name in the welcome message. If we inspect the element, we see our payload. Seems simple enough, right? Now let's try injecting JavaScript and see if we get code execution. Let's try the alert box again. Nothing happens, chat. Now, we were able to inject HTML, but not JavaScript. Now, if I inspect the HTML, we see that our JavaScript or our payload was properly injected. Any idea what went wrong? Let me scroll in a bit. We can check if it was HTML encoded. We can edit as HTML. And no, it was not HTML encoded for this specific case. Now, some of you seem to have the idea. So let's go through this each step from the time the request is sent, when the response arrives, and look at anything that could be causing issues. Let's go through burp again. Now, I believe it's this one. Yes, it is. Now, our payload is URL encoded, just to avoid issues with the browser or with the web server interpreting special characters. This is all good. Now, if we examine the response, specifically where our payload should be, what do you notice, chat? Exactly. The content was added after the page was loaded. So some form of JavaScript is dynamically changing the contents of the web page at runtime. Let's try looking for JS scripts that could be doing this. Go to debugger. And we see here a file called survey.js. Now, this JavaScript file matches our web app name. So this could mean that this JS file contains the logic related to the survey app. Now we immediately see our welcome message being updated. And we see the params.name being appended. Now what is params.name? Now if we look a few lines up, we see it being initialized. Now it starts with initializing the URL search params object with windows.location.search. Windows.location.search contains the query string of our GET request. So basically what this all means is params.name is the get parameter or the value of the get parameter name, which is our payload. Now, so all seems good, right? A lot of you said that it's due to being appended or being inside a p tag. Or you might think that the issue is that our payload is being dynamically added. Now, both of these will actually should work. You can add scripts dynamically like that, or you can insert them inside p tags. But the real problem is this part here, inner HTML. Now, scripts added via inner HTML property will not be evaluated or executed. We actually have, let's see how it's here. So it says here, script tags will not execute when added via inner HTML. However, there are ways to get around this, which we will go over. So inner HTML doesn't mean that you will totally avoid JavaScript execution. It's just that it was designed so that script tags will not work. There are ways to get around this, which we will go over. It actually goes over it here. Basically, using an image tag. Now I saw in the chat someone suggested using image tag. Now what this does, yes, exactly, the on error one. So what this does is by setting the src to an image that doesn't exist, this causes an error and will execute the function or the JavaScript function specified in the onError property. Let's try that out. So let me copy it. And then rather than script tags here, we'll use this one. Let's try this out. And we get our pop-up. Let's try this out on our victim as well, just to be sure. Perfect. All good so far, chat? Nice. Now, for this scenario, our payload is in the URL, so it's also reflected. But unlike earlier, since the server response does not contain our payload, it was dynamically added via JavaScript. Now it's called, it's a type of reflected client XSS. Now, so we finished both reflected server and client. Let's move on to stored XSS. Now, unlike reflected XSS, stored XSS does not require specially crafted links. Instead, any user that visits the vulnerable page rendering the payload or rendering the stored XSS will be exploited. This is because the payload is not in the URL, it's stored in the server, either in a database, a file, etc. Once the server responds to a request, it extracts the payload from wherever it is stored and then injects it or includes it in the response. To showcase this, we'll be working with the blog application. Now, for web apps like blogs, social media, forums, review sites, basically any app that has a lot of user-generated content displayed for other users to consume is always a great target for stored XSS. Now, a quick glance at this web page shows us that comments of other users are displayed for all visitors to see. That means that comments are most likely stored in the server and retrieved once it needs to build a page. The bottom of the page, we find that the app allows us to post a comment. Now, if our comment will be displayed in this web page, let me clear this. This will be a prime target for stored XSS. Let's try that out. Let's have username JSON and a comment called test. Perfect. So now, as before, let's start it off with HTML injection. We see our payload. This time, rather than being treated as HTML, it's displayed as text. Chat, any idea what happened? Why is our HTML tags treated as text rather than HTML? Exactly, nice. So there might be encoding going on. We can check that out. If I click edit as HTML, it's HTML encoded. So that means now most likely it will be difficult, or the server is doing output sanitization to make sure that any input is not treated as HTML, but rather just pure text. Now, even though one input we control, which is the comment, is not vulnerable, does not mean that all of the application is not vulnerable or is secure. We can never be sure if the same checks are in place for all inputs, so we should always test wherever. Now this time, rather than trying it on the comment field, let's try it out on the username field. See, one of them looks different. Our latest comment has a different format than our previous comments. So we are actually able to inject HTML, but not on the comment input, but on the username. So all that's left is to try this with JS. Perfect. Just a reminder, chat, that when testing for XSS, always be thorough. You should always test all available input and not just a few select ones. Now, as I mentioned, since this is stored XSS, the URL does not include our payload. But if any victim visits this web page, they will still be exploited. Now, if you look at the response when browsing to this web page, we see that the server added our input or our payload. So that means this is a stored server XSS. All good so far, chat? Great. So now, let's move on to the last type of XSS, which is stored client. We will once again return to the survey form. Let me clear this. Sorry about that. Some misclicks. Now, earlier, we toyed around with the name parameter for our reflected client XSS. This time, let's play around with the actual survey functionality. Let me give you some background about this web app just so we know how this works, or you know how this works. Now, this survey, or the respondee of this survey, is specified in the URL, which we found out earlier. We can only use a name once when answering the survey, but we can't keep submitting surveys as long as the name is different. Let's try answering the survey as the user JSON. So let me see what questions there are. So let's say this one requires integer, text, integer. Now, once we enter everything, you might have noticed that the table was initially empty and was later populated with our survey results. This could mean that the updates are being done by client-side JS. We will look into that later. So we can view a user's survey result by specifying their name and the get parameter result with no value, as you can see here. Now, earlier we had issues with this web app since our input was being injected into the HTML via inner HTML, if you remember. Let's check the JavaScript just in case the survey app is also using inner HTML, just so we won't experience that problem. If we scroll down at the bottom, we see a function called getData. Now, getData uses Ajax to query or to request the survey or the survey results of the name specified by the get parameter name. See it here. Upon obtaining the response, the table is then populated with the survey answers. So you can see here the key, which is probably the age, city test, or age, city, winter, drive, music. And then the value, which is our survey answers. So our survey is being added directly into table columns. Now this means we can add scripts without issues. So let's fill out another survey. This time, let's try with HTML injection. Let's say the name is HTML attack. Now, we can make this simple and just add the HTML tags in survey form or in fields that accept alphanumeric characters. But let's make this interesting. Let's see here. This allows characters. This also allows characters. I believe this one does not. So chat, any idea how we can bypass the input checks happening here? Nice, exactly. So one method, we'll go through, actually there's two here, is we can use burp to intercept our request and modify it there. That way, we can bypass any client-side checks present. Alternatively, if we look how the client-side check works, in this case, it's actually really simple. It only uses the type property of the input field. It's set to number. Now, this property differs in behavior depending on the browser you use. In Firefox, I can input text, but it will not be accepted. In Chrome, I can't input anything other than numbers. So let's change this to text. And now we should be able to inject HTML. Let's try something like this. And let's also try intercepting our request with burp. There you go. So I can also modify any value here to bypass any client-side checks. Now let's try that out. Let's do the JavaScript injection as well, just so we save time. And let's look at the response. We get our pop-up and we also get our HTML injection. So this is why client-side checks should only be present to help with user experience. Should be there to guide users on how to use your application or how to fill out forms. But you should always have input validation in the server side, as it's super easy to bypass any client-side checks. Now, with that chat, we've gone over all 4 types of XSS: reflected server, reflected client, stored server, and stored client. Hope you learned something today. And with that, the demo ends. Any questions you might have, we still have a few minutes to go through them. My pleasure. Thank you, chat. Now, so this module really went through, shall we say, the theory behind XSS. Following modules will go through more advanced attacks, but it's important that you guys first understand the basics of how XSS works before you can move on to more complicated exploits. It's going to be easier to do more complex attacks if your foundation or your fundamentals are really strong. Once again, my pleasure. And it doesn't seem like we have. I'll wait a few more moments for questions, and then we'll start the song. I'm glad all of you had a good time, and I'm glad all of you learned something. Yeah, next session, I believe we will have the WEB-200 content creators have a talk. Next session will be the creator of WEB-200. He will talk about the course. So, thank you all for coming once again. I appreciate the time. And with that, let me start the song.
Yeah, all I've said, yeah man, I'm gonna tell him say, offensive security, All OffSec, them are the very best. Yeah man, All OffSec for penetration test. Penetration, yeah. Who's OffSec? Go educate the rest. We call the expert DV online training OffSec. Room for me, Servus. You must try harder to keep up the pace. Come now. Otherwise you will be a big disgrace. Disgrace. Tell the competition them to take a rest. OffSec or run the game like me suggest. Yeah. Game run the Wild West. OSCP and OSCE, OSWP and OSAA. OffSec up on like lion pon Serengeti. And I turn them fire while shooting at the confetti. When you have computer system in no integrity, and you need to give a test, call OffSec, you see. Best defense of what offense said they won't chop them, see. Proactivate your cover, they get that security. Sniffing and diffing and hacking and cracking. Now send the competition, crying and packing. Spoofing and coding, debugging and scanning. Delivering the good like them name Peyton Manning. Reversing what the competition cursing. Them fishing, them wishing, what the other them just wishing. Employing exploits with the samurai precision. OffSec company, them are division. All OffSec, them are the very best. The best. All OffSec for penetration test. Penetration, yeah. Who's OffSec? Go educate the rest. We call the expert DV online training OffSec. Room for me, Servus. You must try harder to keep up the pace. Man, boy. Otherwise you will be a big disgrace. Disgrace. Tell the competition them to take a rest. OffSec or run the game. Let me suggest the game or run the Wild West. You are a hero today, but boy they found ya 0 day. Them the Navy seal the cracking, sell a lot the number packing, and the rest of them are infantry. Them a king of the bugging, no so them a straight tugging. When they come to the legal acting, not the other skills lacking. Them say try harder, them resolve and never swear. At the street and not the big competition second grade. The rest of those noobs who run the tools, say them not have what it takes to break the rules. Run them call it Linux like a Jedi master. Breaking out your system like a full-time blaster. Check the counter, boy, you know you have to cop it. Android system, you can hack from your pockets. All OffSec, them are the very best. All OffSec for penetration tests. Who's OffSec? Go educate the rest. We call the expert DV online training OffSec. Room for me, Servus. You must try harder to keep up the pace. Otherwise you will be a big disgrace. Tell the competition them to take a rest. OffSec or run the game. Let me suggest the game or run the Wild West. Can't test OffSec. Can't test OffSec. Oh, can't test OffSec. Can't test OffSec. Oh, pa ping ping ping. Hey, yeah man. Check net hunter boy, you know you have to copy it. Android system, you can hack from your pockets. Offensive security. Yeah, all OffSec, yeah man, I'm gonna tell him say offensive security, All OffSec, them are the very best. Yeah man, all OffSec for penetration test. Penetration, yeah. Who's